We are back, and in this video we're going to cover some important concepts that you will need to know. We're going to start with the coil command, or the coil activity, and what that basically does is it lets you make a spring. So we're going to start with a new millimeter project, create, and off we go. So a coil, you can think of it as a spring, but one of the things it does that's really interesting is you can use it to add material, or you can use it to remove material. Say like you're threading a piece of rod to make it into like a bolt, or a hollow piece of metal and put threads in it so you can thread a bolt into it. You can do that with this command. So I'm going to show you the basics on how this command works. And let's get started. Essentially what you need is a shape and a center line for that shape to revolve around. And that's it. Now making an example here. Let's choose, I'm going to choose a different plane that we usually do. Let's choose this one here, the YZ plane. And let's just keep it simple. Let's draw a little circle way over here somewhere. And we'll make it probably, well, let's make it 10 millimeters. 1, 0, there. Where did it go? Well, let's zoom back. Yeah, it slid over. Dimension's still on. Let's set the dimension to the center, and let's make that 40. Okay? So, and what I mean by center, there's the center of our plane that we're working on, our working plane. One of the default ones. And what I'd like to do now, well, we'll save our sketch, because we essentially have enough that we need to make this thing revolve. And so the question is revolve around what? Well, we are working on the right side. What we want to revolve it around is one of these axes. We can use an axis or we can draw a line. It does have to be a straight line. So let's make this y-axis visible. Okay, so now we can see it, we can click on it. We are ready to do the coil command. I keep calling it revolve, it's coil. So we'll click on coil, and the things that it needs, the minimum it needs is it needs a profile, and it needs an axis to revolve around, and then it needs to know how big you want to make it. How do you want to size it? So let's provide the bare minimum. So we're going to zoom this out a little bit. So it's 10 millimeters in diameter. Now, profile allows you to choose a drawn object to use to spin around an axis. Being that there's only one sketch, it automatically defaults to it. How nice. Thank you. So, the thing we do have to determine is what to revolve around. And that's when we click on this. You can see the blue background means we can select. We're going to select that one. And now, if you can see this green color coming up, it's kind of faint. I see it's making one revolution. And I think I want to change my options, my colors, to sky. Make it easier to see. There we go. Apparently this is a new installation on this laptop that I'm using. And I haven't quite customized it yet, so I just did. Okay, so the y-axis is visible. We've chosen it. Oh, we do need to do the coil command. And it has automatically chosen our circle. We need to pick what the circle will spin around. And now in this darker green, which is much easier to see, we are going to spin it around the, I'll tip it down so you can see it. There. It looks like it's making one revolution, and it has a certain distance or pitch from the center to the new center. So let's go up to coil size and click on it. And I'll show you what I'm talking about. The type of setting that we're working on is something called pitch and revolution. Pitch is 10 millimeters, so it is actually doing a 10 millimeter gap from this to this. And being that it's a 10 millimeter circle, it's going to hit itself. So let's make the pitch 20, and you see how it just jumped right up? Now the whoop, that happens sometimes. All right, let's get it back to normal. Okay, so what we're looking at, here I'll move it up a little bit. We're looking at the distance between the center of the circle to the center of that circle. There, that looks better. Now it's right side up. Is 20. If I made it 12, it's closer. If I made it 15, a little more distant, we'll go at 15. I'm going to zoom it out a little bit because I'm going to increase the revolutions, or the number of times it spins. Right now it's 1. Let's make it 10. There. There are 10 spins or revolutions in that shape right there. Now if I hit OK, congratulations, you now have a spring. And that spring represents 10 revolutions, and the distance between each revolution to the centers of our circle is 15, I believe. Well, we can check it. So if I right click on it and say Edit Feature, Coil Size, it is 15. We could simply change it to 25 if we wanted to increase it. There you go. That's pretty simple. So this begs the question. We'll go ahead and get rid of it. Start in again. That was the coil in its simplest form. So if I delete the coil, and I still have my sketch here, and I'm going to, let's see, we're going to turn it to the right so we can see it. Now, 10 millimeters tall. What if I edited this sketch and shove it down here? What if I drew a line from, say, there to there? Okay. I just drew this line. Okay, so I finished my sketch. Now let's try the coil command. The coil, the profile is already chosen. I can see that. But my axis, instead of using the y-axis, let's use that line I just drew. Look at that. Here's the interesting part. My line here does not extend all the way down to here. And yet this thing is still revolving around it. So that makes me wonder, I have a nice long line here. What if that line were shorter? And like way up here. Okay. Now isn't that craziness? Let's find out what that does. Hit coil. We can see that's already chosen. Choose our axis. And look at that. It doesn't care where that line is. We could make the pitch 20. And it just seems to be very independent of that line. The only thing that line seems to provide is an angle. So keep that in mind when you are making a guideline here, or as they call it, an axis. That provides a guide. It provides an angle, a reference basically as to what to revolve around. And it does not have to be a full length, and it does not have to be touching it really. So we can OK it, and we'll see that, hey, it works. Now let's go over some of the features of the coil. We'll go to Edit Feature. And of course we know Profile. That is the circle that's chosen here already. We know Axis. That's the line we chose. Okay. coil size. So, oh, by the way, if I clicked on this entry here, it reverses the direction that the coil goes. Okay, this is your direction. So I'm making it go to the right or up. Now I'm making it go down or to the left. Okay, so that's interesting. Now, what if I wanted to reverse the way it's spinning? For instance, right now it's kind of revolving counterclockwise going up. What if I click on this? Now it's revolving clockwise going up. So yes, you can make left-handed and right-handed springs or threads if we were threading something with it. So I'll go back in here, go edit feature again. So we've explained the axis, the profile, the axis reverse settings. We are outputting a solid. We could output just a surface, which would be a hollow. It doesn't take up any room. We've talked about making a new solid, which it is. Rotation is reversible. Let's talk about coil size. Pitch and revolution. We know that the pitch is 20, which means that the gap is a distance of 20 between each of these centers of the object that we drew. And we know we want to do 10 revolutions. But what if we wanted to do something called revolution in height? And look what it just did. Revolution in height, what this does, it goes without pitch. Height is the maximum height that you want this thing to be. Like say I want it to be no taller than 50 millimeters and no shorter than 50 millimeters. Oh, that seems kind of small. Let's go 100 millimeters. Okay, so we've gone 100 millimeters and we're making it spin 10 times. Here's what's neat. Let's go 200 millimeters. Okay, 200 is a pretty good size. It's spinning 10 times. Now here's the interesting thing. Notice how far up it goes. That represents 200 millimeters from the bottom to the top. If I wanted it to spin 20 times, it is still that same distance from bottom to top, but now it has 20 revolutions in it. What if I only wanted 4? Same height, 200 millimeters, 4 revolutions this time. So that's what revolution in height does for you. You set how high you want it to go and how many times you want it to turn within that height. So we'll put it back to, let's make it 12. Okay, so that's what that does. Now, let's look at some more options here. Edit feature again. And of course, I'm right-clicking on these objects to get to these menus here. So, coil size, pitch and height. Okay, pitch and height this time. I noticed there's a new feature called taper. Did I have that before? Yes, I did. Pitch and height. So, pitch is the distance between these coils. Oh, revolution in height. Yeah, revolution height was the number of turns. Pitch in height is the height between these two coils and the total distance it can go. So if we made those 20, let's make it 10. So what changes now is the number of spins that it does, the number of revolutions. I don't particularly know how many revolutions, and I don't particularly care if I'm more concerned with the pitch. So if I made my pitch 35 and I wanted it to go no further than 200 millimeters, but it has to spin 35 times, this will set the number of spins that I need to accomplish that. Okay, so that takes care of the math, basically, that we need in order to be able to have it be a certain pitch and a maximum distance, or a set length. And the last one, spiral. This is an awesome one. Check this out. It's a spiral. So it's spinning 12 times. Let's make it 3. There are 1, 2, 3 lines in that. If I make it 5, I've increased it. And if I decrease the pitch to something like 12, they're a lot closer, tighter together now. And I'll make that revolution 10. So the pitch, well, what the difference is, spiral, first of all, is flat. Okay? It's a flat spiral spin. And the pitch is the distance between each spiral to the centers, and the revolution is the total number of times it turns around itself and goes outwards. So if I hit OK, look at that. Looks like a roll of copper tubing. In fact, you could make it a roll of copper tubing if you did something like this. Oh, here, got a way to catch up. There we go. If you did something like this, I'm going to right-click on coil and this time say edit the sketch. This is the drawing we had inside. Now, I have a 10 millimeter. Let's draw a circle inside of it. Okay, and let's make it 8 this time. And we'll type in 8. So there's a distance of 2 millimeters between the outside and the inside diameters. So what did that accomplish? Well, if we go to coil and we edit the feature, and we go and we pick our profile, let's see if it'll let us. I may have to actually delete coil. Let's do that. And we won't get rid of all the sketches inside. What I'm looking for is to be able to choose this outer ring with a coil. Let's see if it will let us do that. Yes, I see that now. Profile is not pre-selected this time. I have to pick it. And that's what I want. Not that one, not both, just that outer ring right there. That's why it didn't default this time. The axis is, well, I could use that, or I could use that. I'll go with that. No, I'm going to change my mind because I can. I'm going to go with that. And of course, we are looking for spiral because that's our example we're using. So we're going to spiral out, and this time it's going to be hollow. It's just going to do that part right there. So watch this. We OK it. Give it some time to think. And I'm willing to bet this now looks like a tube. Yep. There it is. It's hollow inside. Fantastic. And of course, if you modify the sketch here, modify the feature, I mean, and you change the coil from a spiral to, we'll say I like height. Let's do revolution and height. And I'm not even looking at the thing. I want it to revolve 10 times, and I want it to be 200 high. So 200 up, spin 10 times, hit OK. Not even looking at it. Now I'm going to click on the right panel here, and there it is. Just like we ordered. Didn't even have to look at it, and we managed to do it just by instructions alone. And it is a hollow tube going up, or hollow spring spiraling up. Okay. So that takes care of those basic features to this. Yeah, we could draw a surface variant of this. Probably not going to use it much. Okay, so we've covered everything in coil size. We've covered the majority of coil shape. Now let's tackle coil ends. Okay, right now, this thing starts, here, we'll turn it to the front. It starts here at this y-axis and revolves around until it gets up to the top, and it ends right straight above itself. Okay, so you see that. Here, we'll click it on front. In fact, I'm going to take a snapshot of that right there. And there's our snapshot. And so what I want to show you is that this right here and this right here are straight above each other. Okay? Okay. Now go back to Inventor. Let's modify under Features, a coil end. Let's start with the end. We'll change it to flat, and we will change a transition angle to 90 degrees. And that's all we'll do. And now watch what it does. Okay, that's very different. So here's what it's doing. We'll take a snapshot of it. Okay, so I've taken a second snapshot here. So what we're looking at is that was the original, and this is the new one. And you can see way over here, they don't line up straight above each other anymore. Okay, there's the original. Here's after we added a 90-degree transition angle. So we'll go back here to coil, edit feature, coil end. That's with a 90-degree transition angle. Okay. "90-degree transition angle." Okay. There is another setting you can add to this, and that is flat angle. We'll add 90 degrees to flat angle. Let's see what that does. Okay, so here's the interesting thing about a 90-degree flat angle. Is it has taken that spring, and if you look at it here, we'll take another snapshot of it. Okay, so this time what it did, the first 90-degree transition started about here and ended here. And then the second part started here and ended here. But what it did was this whole part became flat rather than continuing to spiral up. The gap between each coil is shrunk down quite a bit right in here. So let's go back to Inventor and you'll see it. We'll tip it up on its side. You can see right there, it is flat. We'll take another picture of it. And right there, flat. And if it didn't have, we'll go back to the original, not flat. There's an angle to it right there. So you can see the setting flattened it down in order for it to turn a little bit further and stay within the parameter that we wanted it to be, which is, I believe, 200 millimeters. Let's take a look. Edit feature, coil ends. and coil size was 200 millimeters with 10 turns within that 200 millimeter space. So it actually changed the distance of these coils a little bit. It adjusted them so that they would still be 10. It may have even added a little bit here, because that's kind of what it tends to do. But it certainly flattens out that top coil, or the end coil. We are at the end of it. Now we can do the same thing with start. So let's take our coil here and set all back to 0. Actually, we can change it back to natural. And natural just makes it look normal again. So if we spin this around, you can see it's back to normal, where the ends start and finish straight across from each other, even though they're offset by 200 millimeters. Okay, so let's change our settings in. I'm going to close up some of these here. There. So let's make a change to the start. Add a feature to the starting coil end. We'll make it flat and we'll make that 90. We'll make this one 0. So the transition angle is 0. So what that did was, with setting a transition angle, it pushed that top one around 90 degrees extra. And it shifted the coils a little bit too. So what we're looking at is this is still in the same place that it was, but this end here is where all the commands were activated. And by shifting all of this and maintaining uniformity, it forced this one to go around 90 degrees extra. So it turned the corner. It used to end right here. Now it ends over here. Okay? So we'll erase that. And if we go back to Inventor and we add the flat, so we'll edit the feature, coil ends, we'll add 90 degrees to that, to the flat angle. It turned another 90 and now it's on the opposite side. You'll see that here in just a second. And it did. So the interesting thing, and we'll take a snapshot of it. Okay, the interesting thing is here it was with just the first 90 in the transition. Here it is. This right here became flatter. In fact, this part right here is relatively flat. And it's flat for 90 degrees going around the bend. All right. And then the next 90 degrees was stretched out to push this over to that side. So that right there used to end here. Now it's actually made its way 180 degrees total to the opposite side. 90 and 90 is 180. So what does this do for you? So what this does for you is, by changing the coil ends, what that helps you to do is, if you are making a coil object of some kind and the ending spot on the coil needs to move more to the right or more to the left, you can do that with these commands. You can stretch it out a little bit further, you can flatten it down a little bit further. A lot of times people will design it so that it stretches, it flattens down, so that it can be put in some kind of a object a retainer so it doesn't cut into it. Being flat makes it ride in some kind of receptacle better, especially like car springs. If you have a car spring and it ends like that, that could cut into the part that it rides on. But if it is flat like down here, then all of this makes contact with the metal that the metal container has to sit in. And so it tends to wear it a lot longer, or does not wear it out as quickly as this will. This will chop a hole in it eventually, whereas this will take years. So that's what the advantage is. And then of course if you did flat and made them all 90, you can see how this thing was shifting. You'll have nice ends to both ends of the spring. There you go. They start out flat and it ends flat. And interestingly enough, it looks like it did when it was all natural, just not sticking up and sticking down. So that would be a properly designed spring right there. Okay, that should take care of springs. So if you were to kind of start over and you were to draw a circle this time, I'm not going to worry about the top thing because it's all round, and we'll make the circle 20 millimeters. How about that? 20 millimeters in diameter. We'll make it 200 tall. Good. And the y-axis is exposed so we can see it. Very good. Okay, let's pick a plane. That one. And let's sketch on it. Okay. If I were to draw a triangle down here, and I'm just going to do a sketched one myself. So I'm going to start this corner here, go up about 3 is good. Go this way, and then this way. Okay. Now I'm going to escape. Where did my triangle go? Well, here's something that you'll find handy. Under the View tab, you can go to Visual Style. You can change it to a wireframe. Usually it's a shaded or shaded with edges. We'll go to wireframe. Oh, and I see I am missing part of my line. So I'll go back to the Sketch tab, which is in blue. Click on Line. Bring this over here and try and find, there it is. That little green dot represents the end of the line I started with. Okay, so now I have a triangle here. That's going to be what I call my cutting tool. So we'll finish that sketch, and we will rotate it so you can see to the right, I believe. Yes. So now I want to use the coil command. Good, that was chosen. And we will choose the, click on it again, the y-axis. If I can get it. One more time. Now it's blue. Now it should be, yes, it was choosing it. I just didn't see the little yellow guy down here. Okay, so that's what it's doing. Coil size, pitch, let's make it smaller. Let's make it 9. And say OK. And you don't see anything. Well, let's go, that's because, first of all, add a feature. You need to make sure it's cutting the material. Now you see something. Okay. That's starting to look like a threaded screw, isn't it? So what if we were to edit the feature again and tighten it up a little bit? Instead of 9, let's make it 6. And let's go for 5. Okay. Let's try 4. And OK 4. There. How about that? That's starting to look like you're threading a bolt. And if we go back to View and turn the style back on to shaded, It looks very much like a bolt, doesn't it? How about that? There's a lot of science involved in making these things, and it is going to be a project that we tackle later. I want to show you the extent of this command, of the coil command. And you can see it's handy for making threads. Now, in Autodesk, as in other programs, they do have a thread command. But what I have discovered is, even though there is a thread command here and it makes a graphical representation simulated of threads on something, the problem is that when you 3D print it, they're not there. But if you draw them this way and use the coil command and the proper parameters, they will be there, and you can 3D print a threaded hole or a threaded bolt, and it's very, very handy. Okay, I think that's enough on coil. But wait, there's more. One more thing to show you about the coil command, and that is the taper that I alluded to earlier, the taper feature. Well, let's throw something on here. We shall start a 2D sketch. We'll pick that plane right there, which is the right side. And just to prove a point here, we'll throw a circle here about, just under 5 millimeters. And then we'll grab a polygon, a 5-sided pentagon. Why not? And we'll make it roughly the same size. Okay. And of course our y-axis is exposed. We have it visible over here. That's what I mean by exposed. So let's demonstrate the... Oh, and don't forget to finish your sketch. There. Now we'll straighten it up so we can see it real well. And let's demonstrate the tapering a coil. So, of course, we go to Coil, Profile. Because I had 2 sketches I drew on purpose, you have to choose one or the other, and unfortunately you cannot choose both. I tried that and it didn't work. It does work in Creo. That's one of the few things that works great in Creo. So anyway, you do just choose one here. I'm going to choose the pentagon because I wanted it to be an odd thing. Profile will be the y-axis. I'm sorry, the axis will be the y-axis. This is the profile. And the coil size. Alright, so normally it's tapered to 0. Okay, and this is kind of what it looks like. Nice and straight up and down. Let's modify it. Let's change the taper to a minus 1.5. Well, let's make it even bigger than that. Let's make it minus 2. Let's make it minus 3. Let's make it minus 4. You can really see how it's tapering here as you increase negative taper. As you can see, angles it inwards. So what does that mean if you use a positive number? Like I'm about to change it from negative 4 to a plus 8. And there you have it. You can see what taper does. It actually tapers it so that it increases. It's almost like combining the spiral and the coil together. Okay, so it's adding like a spiral that gets wider and wider and wider as it coils upwards. So it's a very clever combination of the two, and you can get some objects that would be very hard to draft any other way. So that's taper. I just wanted to show you that. Okay, that is enough of coil.